Notes 7.5 are on the topic of strategies for integration. We're going to use this section as a way to kind of go back and review everything we've learned so far. And so the examples that I'll provide you touch upon various strategies that you have learned. The first example is a fraction. The degree of the numerator is 1, the degree of the denominator is 2, so I don't need to divide. Instead, I have a quadratic downstairs and just a monomial linear upstairs. So this means I can do u substitution. So let u equal x squared minus 1 and go from there. The next example has the same two players, but this time the x squared term is on the top. This time the quadratic polynomial is on the top and the linear is on the bottom. You might think we have to do division right away, but it doesn't have to be long division because that's just a monomial in the bottom. What I'm going to do is divide each term on top by x on the bottom. X squared divided by x, I'm going to do that, and then minus 1 divided by x. So that's what I'm thinking of, and I'll get the integral of x minus 1 over x, and we can just take the antiderivative now. 1/2 x squared minus natural log of absolute x. Okay, the next one has the quadratic on the bottom, but now that's not a linear on top, that's a constant on top. U substitution will not work. I can, though, look at this because the denominator factors, I can look at it in partial fraction decomposition mode. So the denominator factors into x plus 1 times x minus 1. And remember, we're going to take that fraction and set it equal to the sum of two fractions. The denominator of one will be x plus 1, and the denominator of the other will be x minus 1. And they're just simple linear factors down there, so I could just put an a and then put a b on the tops. Let's solve for a and b. Don't get thrown off by the next example. The next example is just simply arctan x. That's the derivative of arctan sitting there behind that integral symbol. Pay attention and look out for that one. That one always shows up on the AP test. Now we have one of our newer strategies. The numerator is a quadratic, denominator is a linear, and it's not a monomial. So I'm going to use long division. X minus 1 is the divisor, so it goes outside, and I like to put a term for every power in the dividend. So x squared is already there. Then I'm going to create a 0x, so I have an x to the first power column, and then a plus 1. X times what would get me x squared? Well, that would be a single x. And now I'll multiply. X times x is x squared, and x times -1 is -x. Draw the line, change the signs, and add down. X times what gets you x, and that's just +1. So when I multiply, I'll get x minus 1, draw the line, change the signs, and add down. Our remainder is 2, so that goes on the top of a fraction. The divisor, x minus 1, goes on the bottom. So now our integral looks like x plus 1 plus 2 over x minus 1. And now we can find the antiderivatives. So we'll get 1/2 x squared plus x plus 2 times natural log of absolute x minus 1. I would like to do this one first by letting u equal sine. du would be cosine dx, which is what we have on the rest of the integral. So the integral would become 1 over the square root of 1 minus u squared du. This is actually the derivative of arcsine. So this is arcsine of u plus c, otherwise known as arcsine of sine x plus c. And look what I just wrote there. The arcsine of sine x, that's taking the inverse sine of sine, which just gets you x. So those two functions undo each other. Arcsine undoes sine. And we end up with x plus c. Maybe you realize you could have done this problem with a different approach. Did you notice that underneath the square root is 1 minus sine squared? Well, 1 minus sine squared is the same thing as cosine squared. And you're taking the square root of cosine squared, which would be cosine. That gives us cosine divided by cosine, which is 1. So the antiderivative of 1 is x. And the answer is x plus c. This next math problem looks crazy. I'm going to let u equal natural log x and try to simplify how this looks. The derivative of u then is 1 over x dx. And look at, there's a 1 over x dx in the problem. So 1 over x dx is going to get replaced by du, and we're left with 1 over 1 plus u squared. Do you remember what that is? That's the arctangent of u. The derivative of arctangent is 1 over 1 plus u squared. I need to bring x back in place of u. It was natural log of x, and that's your answer. The next example is some reviewing of trig functions once again. This one might be helpful if you remember your cosine squared substitution. Remember, cosine squared can be substituted with 1/2, 1 plus cosine of 2x. And remember that whatever angle you have after the squared term, you actually double the angle when you make this substitution. So I'm going to write this down here. Cosine squared is going to get replaced with this 1/2 parentheses 1 plus cosine, and I'm going to double the angle from a 3x to a 6x. Let's put that 1/2 out front, and we'll take the antiderivative. So the antiderivative of 1 is x. The antiderivative of cosine 6x is going to be sine 6x with a correction factor of 1/6. So distribute the 1/2. 1/2 x plus 1/12 sine of 6x plus c. I'm looking at a sine cosine integrand with an odd power. If you remember, we're going to take 1 away from the odd power. Since sine is to the odd power, we're going to take out a sine. And when you take out sine, that lets you know to let u equal cosine. Well, I'll rewrite this first. So I'll have sine to the first times sine to the fourth times cosine to the fourth dx. I'm going to replace sine to the fourth. Sine to the fourth is sine squared squared. Sine squared gets rewritten as 1 minus cosine squared. Don't forget that's squared. And I'm ready for the u substitution. Let u equal cosine. Du is negative sine. And so I'm going to replace sine x dx with negative du. So here's sine x dx with negative du. So put the negative out in front. We will have 1 minus u squared, quantity squared, and then we'll have a u to the fourth and a du. First I'm going to square the binomial. So I'll get 1 minus 2u squared plus u to the fourth, and then I'll distribute the u to the fourth into the parentheses. U to the fourth minus 2u to the sixth plus u to the eighth. Now I'm ready to take the antiderivative. That's negative 1/5 u to the fifth minus 2/7 u to the seventh plus 1/9 u to the ninth plus c. And all you have left to do is bring cosine back in for u. I'm going to distribute the negative when I do that. I'll get negative 1/5 cosine to the fifth plus 2/7 cosine to the seventh. Don't forget to bring the negative in. We're distributing the negative. Minus 1/9 cosine to the ninth. So the strategy here, if you remember, is when cosine and sine are together and one of them is odd, you just need one of them to be odd. They could be both of them odd, but one of them is odd. So you take out one of them from the odd term and work with the even copy of that function. Now it's time to review integration by parts. Are you recognizing we have the product of two functions and we have a polynomial, but we have natural log? So my first inclination is usually to let u equal x to the third because it is the polynomial. But since the other function is natural log x, I'm going to set up the small chart and let u equal natural log x and let dv equal x cubed dx. I can get the derivative here and the antiderivative here. U times v minus the integral of v du. V is 1/4 x to the fourth. Du is 1 over x dx. So the x on the bottom is going to cancel with one of them in the x to the fourth. So this is the integral of x to the third. Let's take the antiderivative. I think you might have fun on the last one. It has a polynomial, x squared, and it has an e to the x, which is not natural log of x. So why don't you try this one on your own by pausing the video, do this on your own, turn the video back on to see if you got the same answer. Did you use tabular integration? Look how quick it went with tabular integration. If you did not use that, please turn your paper over, try to do the math problem again with tabular integration, just to practice it in case you didn't do that the first time. Okay? Good job. Now it's time to work on your homework.